All right, part two of instruction from 217, another e-learning day. So we're going to do a couple ionic compound Lewis structures as examples. So calcium chloride, remember calcium will be the metal. It's going to want to get rid of its valence electrons. Chloride is going to be the nonmetal. It's going to want to gain those electrons. So if you have it or don't have it readily available, make sure you have that. So let's look. It is calcium chloride. Calcium will have 2 valence electrons. Chloride is chlorine if it's happy, and we'll have 7. So remember, the nonmetals, it is whatever the group number is minus 10. So chlorine will have 7 valence electrons. So first step is just draw a symbol of each with its valence electron. So draw the Lewis structure. So calcium has 2. 1, 2. Chloride, capital Cl, has 7. 1, 2, 3, 4, 5, 6, 7. Go ahead and draw brackets. And then what's going to happen is electrons are going to transfer. So this electron right here, notice 3 of the 4 sides have 2 electrons on it, but this one does not. So this is a lone electron. These are paired electrons. The lone electrons are where the action is going to happen. That's where the bond is going to take place. So this electron is going to transfer, create an ionic bond, and it's going to go here. So when it does, I erase where it came from. Whoop. And notice this chlorine now has 8. It has met the octet rule. So it is happy. It just gained 1 electron. It was neutral with 7. Now it has 8 electrons, so it is negative. Right now, this calcium was neutral when it had 2 electrons. It now has 1. It is less negative. It is positive 1. But this chloride is stable because it's met the octet, but this calcium still is not. So what do you think is going to happen? Well, it's going to find another chlorine atom. Remember, it has 7 valence, so go ahead and draw those. 1, 2, 3, 4, 5, 6, 7. And this electron is going to transfer here. And I'm not going to draw the arrow because I'd have to erase it, but hopefully you were paying attention. Draw the bracket. And this became a negative 1. Well, now that is a positive 2 because it lost 2 electrons. Each of these lost 1 electron, so these are each negative 1, but the net charge is still neutral. Positive 2 here, minus 1, negative 2, net charge of 0. So that is how you draw the Lewis structures of that. The formula there for this compound calcium chloride, you have 1 calcium and 2 chlorides, would be Ca, remember the metal always goes first, and Cl, and how many do we have? 2, so that'd be a subscript 2. Remember, this means the ratio of chlorine atoms to the ratio of calcium, and it's a 1 to 2. If it's a 1, you omit the subscript of 1. You just leave it there. So calcium chloride is CaCl2. Let's do lithium oxide. So first step, periodic table. Lithium, 1 valence. But be careful, what about lithium? It has that 1 valence is in the second energy shell, and it wants to get rid of it. So lithium, remember, it wants a duet rule. So it's going to only have 2 electrons at the end. Let's go ahead and draw it. Li, 1 valence. Oxide is oxygen, if it got happy. So here's oxygen. So it is 16, so it'd have 6 valence. So draw an O, capital O for oxygen, 6 valence. 1, 2, 3, 4, 5, 6. And what's going to happen? This electron is going to find a side with only 1 electron over here, and it's going to transfer. So go whoop and go right here. And when it did, this becomes erased. And this lithium was neutral, just lost an electron, is now +1. So this lithium is now happy because it has a full valence shell. This oxygen, however, does not. It has 1, 2, 3, 4, 5, 6, 7. So it's going to want to gain another electron. So it's going to find another lithium with 1 valence, just like before, and it's that electron is going to transfer and go right here. So when you do that, make sure you erase the old one. And now you insert your brackets to indicate that the number of electrons has changed, meaning a charge. So remember, this lithium had 1 valence electron, and it lost it. Electrons are negative. Losing a negative is minus a minus. Lithium would be a +1. This oxygen, it started with 6 valence electrons. Now it has 8. So now, since it gained 2 electrons plus -2, it is now a -2 charge. I may have misspoke there, but hopefully you followed along. Let's do strontium sulfide. So remember, strontium's the metal, sulfide is the nonmetal. So strontium, right here. Just a little recap. If you can't find it and you're on digital, hit Control F and then start typing it. And notice it shows up right here. So strontium, capital S, lowercase r, 2 valence electrons. So strontium, capital S, lowercase r, and 2. 1, 2. Sulfide is the nonmetal. It is sulfur, if it were happy. Sulfur is commonly misspelled. So notice on the left of your screen, it's not pH, it's FUR. It is in group 16. It will have 6 valence electrons. That's a dot. So at this point, remember, strontium's wanting to get rid of its electrons, and this electron found a spot, so it's going to transfer. This went here. So then you erase where it came from. Now at this point, this electron, or this element, strontium, still not happy. It has an electron, not a full valence, so it wants to get rid of it. Same with this. This has 7, it wants 8, so it's going to transfer. So this would go here. At that point, we'll move this electron. brackets around it, each of them. And then remember what it started with, how many valence it started with, and how many it ended with. Remember, electrons are negative. So strontium, it had 2 valence electrons. They got rid of it. Electrons are negative, so minus a negative is really positive, and there were 2 of them, so +2 here. Sulfide, it had 6 valence. It gained 2, and it would be -2. Again, these net charges need to balance out. All right, and we'll do the last one for today, calcium phosphide. So pull up your periodic table. Calcium, capital Ca, 2 valence. Phosphide is phosphorus, if it were happy, and this is a pH, not an F. And it is just capital P, and it has 5 valence electrons, 15 minus 10, 5. Phosphorus has 5. So capital P, and it has 5. 1, 2, 3, 4, 5. So calcium wants to get rid of it, and I see a place right here for this one. So whoop. And then it goes there. I erase it. And we look. This is not happy. It's still got an electron. This one's wanting 2, so it's not happy. So we'll go ahead and transfer this one right here. And let's just say it goes right here. It just found a home. So we erase it. Once it's happy, put a bracket around it. Remember, it had 2, and it lost them. Minus 2 plus 2. Well, now it looks like we're out of electrons. So at this point, what are we going to need to do? Well, we're going to need another calcium. And how many did it have? 2. So we go 1, 2. One of these will go here and erase it. At this point, this phosphorus is happy. And it started with 5 and it gained 3. So it's a -3. But if you notice, well, now we have a calcium down here, and it's not happy. So what are we going to do? We keep going. So now we add another phosphorus. How many did it have? It had 5. Ooh, that's better. This calcium's like looking for a spot. And we'll just put them right here next to this ugly guy. At this point, this calcium's happy. It just lost its 2 valence, so it is a +2. So now we have this phosphorus. It has 2 on this side, 2 on this side, but it's missing here and here. So what's going to happen? We're going to get another calcium. Calcium has 2 valence. We'll put it here and here. And then what's going to happen? It's going to try to get rid of it. And it just found a spot right here. So when it moves, erase where it came from. None of them are happy yet, but they're getting close. So calcium, this electron found this right down here. So it's going to move from here to there. And then at this point, this phosphorus has 8. This calcium it's the valence shell underneath it became its valence, so they both achieved full valence at that point. This calcium lost 2 electrons, they're negative, so minus a -2 is +2. And this phosphorus down here is a -3. So notice they're -3 is -6. 2 + 2 + 2 is +6. The charges balance out. So what is the formula? I forgot to do it over here. The formula would be Ca, and how many do we have? We've got 3 of them. So Ca subscript 3, capital P. How many phosphides do we have? We have 2 of them. So that is the chemical compound here. Here, we only needed 1 of each. So strontium sulfide would just be SRS. Here, let's see if I can scroll up. Not easily is the answer. There is 2 lithiums, so 1 oxygen. So that'd be Li2, capital O. And let's look at the next slide, but I think that does it for today. Well, I pretty much covered this when I did it, but when an element loses an electron, it becomes, oh, I did this backward. When it gains an electron, it becomes negative. So remember, electrons are negative. So if you gain, you are adding. Adding a negative is really negative. That's the best way I know to think of it. Negative atoms are called anions. The next slide is just the inverse of this. If an atom loses an electron, it becomes less negative, which is positive. You are minusing a negative. Minus a minus is positive. And compounds will need a balanced net charge. And we will stop there.